Now we will see about stiffness. Stiffness means a resistance offered to deform. For example, if we have high stiffness, then if this is our beam, if we have high stiffness means deflection will be less. Here force, when force applied, deflection will be less if we have high stiffness means. Similarly, if we have low stiffness, it means if this is our beam, deflection will be maximum when force is applied. So resistance offered to deform, that one is called as stiffness. Okay, now resistance means resistance is related to now resistance, this one resistance is related to what? One is modulus of elasticity, and second one is moment of inertia. In our case, we have concrete as material. How we will calculate this one? 5000 under root of FCK is our material, concrete material modulus of elasticity in our case. And similarly, moment of inertia in our case, we have geometric, this one is geometric property. It means we have rectangular section, rectangular beam, example, rectangular section. How we will find out the value? If it is rectangular means B D cube by 12 by using this formula. Okay. Now, while modeling in ETABS, we define E as concrete. We define this E as concrete and this I as rectangular section. Here, while modeling ETABS, while modeling in ETABS, we are considering only concrete and geometric property, not considering, we are ignoring. One is presence of steel and second one is presence of cracks. Why? Let's go to IS 456 clause 22.3.1. Clause 22.3.1. See here. Here our code tells us to take the relative stiffness. In relative stiffness, either we can take this that as a gross section or transformed section or cracked section, but we have to take all members as same. If we are using the gross section means all members we have to use gross section method only. If we are using cracked section means we have to use cracked section only for all members. Okay, if we take gross section means slightly not taking the right value, because gross property is a just geometric, but our code allowing this because it is easy to do. So even when you do in your curriculums, while doing the using the moment distribution method, then also you took the gross property parameter only, that is bd cube by 12. Okay, and when we have to use the gross section, it is discussed in our course, and our course you can check in our website, that is www.ehbconsultants.in. You can use this website to purchase the ETABS course. Okay, now let's go to clause 22.3.2 for deflection calculations and appropriate values of moment of inertia as specified in Annex C should be used. So it's telling Annex C should be used for these calculations. Okay, appropriate calculation, we will get appropriate values. Okay, and next, now we will see why cracked section is important. In reality, all concrete cracks, right? In reality, all concrete cracks, right? These cracks are due to many reasons, but due to these cracks, what happens in our structure? First one is stiffness will reduce, stiffness reduces, and due to this stiffness, due to this reduced in stiffness, what happens? Force distribution also changes. How the force distribution changes, we will see now. Let's take here no cracking and here cracked section. If no cracking means this is ETABS model where we are using the gross property. Cracked section means this is real structure where cracks are developed. In reality, we can say in reality this is the cracked section. Okay, we can see the bending moment diagram when no cracking or when we use gross property, then this is our bending moment diagram. Let's take this example as minus 20 minus 20 plus 100. Just example I am taking. So if it is similarly in reality, how it will be? The span moment is maximum compared to this and support moments are less compared to these values. Okay, let's tell this as x value and x value, and this one is y value, and this one is less than x, less than x, more than y, this value, like this. Okay, if it is like this, then how our detailing will be? This is the beam, these are support columns, and this is 2T16 and these are extra bars, 2T16 required, and span moment, for span moments we are providing 2T16 as steel. This is when we use gross section, but this is not a, in reality we won't get this much. Let's check when we use cracked section. This is the reality. Okay, in reality how much we need? This is 2T16, this is 2T16, and this is extra bar 2T16. In reality we need this much. So this is the reality versus gross section, BDQ by 12. Okay, now let's say these cracks are micro cracks, and these micro cracks developed due to tension developed in the members. So predominantly beams are tension members, so beams cracks more compared to columns, right? It is not mandatory that every time the cracks should be visible. It may be visible or it might not be visible. Now, how to capture these cracks in ETABS? The answer is by modifying the stiffness. Each member may crack differently, so may not be possible to capture separately. So that's the reason our code suggests a flat value to modify the stiffness, right? As per our IS 1893 2000, sorry, 1893 2000 clause 6.4.3.1 and IS 16700 2023 table 5. These codes suggest a flat value to modify the stiffness. Okay, now let's see. Walls are what suggested value 0.7 cross section. Okay, similarly for columns 0.7, for beams 0.35, for slabs 0.25 kg. Okay, now we have discussed this in detail in our course, which parameters we have to change in ETABS. So please refer our course. And now our summary is, we are about to end now. What is our summary? Our summary is, first one, cracking reduces stiffness. Second one is, design might be more rigid than actual if we use cross section, then only it applies. Okay, and third one is, due to cracks, force distribution varies. And fourth one is, deflection is less if we are not using stiffness modification. Fifth one is to match reality, we have to modify the stiffness. So due to this, deflection will increase, right? Okay.